Okay, so this is lecture 2, hour 2, and we just heard from Paul Gladen, told us a little bit about what Blackstone does in general and also more specifically here at the university. And so what I thought we'd do next is just review briefly what our own learning goals were for the course, things we did last time, and then spend some time maybe ranking somehow the ideas we had for the P3, which we'll dig into here in a little bit. But let's just look at this and interrupt me if I'm not representing your ideas properly. But so Adam's learning goals, he really wanted to get deeper into some of the economics of conventional versus renewables. And I think we'll probably see as we go through this Lovins book, what some of the barriers are. So I think we also went over my paper from 2008, which I think sheds a little bit of light on that. Why does economics or finance take precedent over environmental concerns? So we did this P3, so people, prosperity, and planet. I called P2 people and P3 environment or planet. How to put a monetary price on externalities. And I have a book chapter that I was going to try to pull in on that. I don't know. Those are easy answers there.
Sorry, it just reminds me of the life of Brian. What did the Romans ever do?
Oh, right. It's been a while, but yeah, I remember a few lines from that movie. And then you'd also like to understand the subtleties of carbon trading and carbon credits. I don't know that much about it. I did just email a buddy of mine today whose son, I want to say, was working somewhere in Africa or Australia, where I think these markets are a little more progressive than they are here in the U.S. And then also, how these markets occur on regional bases. Why is Germany leading in PV so much? Jared Diamond's collapse, I think, answers some of those questions. Right. And then I think, population density to some extent as well. And then this other one, how do various energies come to market, or maybe energy technologies?
Yeah,
is that more?
Or even like if you're trying to develop an energy resource from a landfill or from solar, if you're trying to make your own energy, basically, how do you bring that to the grid? Marketplace.
Okay.
That's like connecting to the grid.
Yeah, sort of like that.
So we could say, how do various primary energies, and in some sense, I guess you call landfill primary energy. It's sitting there in the earth.
It's almost any energy source that you aren't just using yourself, and therefore want to sell and distribute. How do you do that? Yeah. Which is either you've got to connect to the grid, or you've got to have some kind of battery storage that you can.
Yeah. I guess a lot of that kind of depends on whether we ever get to a point where it's decentralized, distributed.
No, I think that's a good question.
Yeah, and then the other one, how are prices determined? That's a big black box for me too. I mean, you would obviously some of it's free market, but some of it's also monopoly.
It's highly regulated.
Yeah. So.
Yeah, I just want to kind of better understand.
Like oil is highly regulated.
Like oil is a global market, that's pretty cut and dried.
The utility pricing is heavily regulated.
I don't understand how the utility pricing of gas and electricity works. That's just one of the things I want to learn.
Yeah, that's something we'll have to dig into. Okay, and then Gary said he wanted to start with a full basis of understanding of everything that's come before, and now he can make an informed decision of how to move forward. So, and he mentioned, Picasso, mastering a lot of different art genres, and then Da Vinci also having a, fairly broad grasp of human knowledge, which I don't think is really possible anymore. But and then, yeah, I guess the Google knows. And then maybe do a few case studies in energy production. There are several case studies in this handbook of energy auditing, like comparing two different technologies side by side. You might have your upfront capital versus your downstream operations and management.
I think so. An interesting one. It sort of relates to your kind of how the technologies kind of market is, this sort of almost local versus kind of distributed energy. So to what extent does an individual in their own home or their own business, sort of the own community, become sort of self-sustaining as opposed to having massive kind of energy power stations that then have to have a grid to distribute it
Right.
to all of us?
Right, yeah. Yeah, and I just bumped into Lisa Swallow yesterday, and everyone's like, oh, yeah, Montana gets 40% of its electricity from hydro. And, well, I mean, if you're right next to the hydro dam, you're getting all of your electricity from there, because it's just, it's a giant network, and it's the energy's gonna flow to where the demand is, but, that said, if you're still on the grid, you're getting effectively whatever percentage of the grid is, primary energy is coming from coal, so, good. And then, he already wants to take the knowledge from number one to make some type of entrepreneurial initiative. And I think you've had a lot of passion for biomass, beetle kill, sort of
It's
lignin.
landfill gas, biogas, municipal waste, you've got, city, bio-wastes, production of methane, you've got methane like down in Derry, you got methane
Mhm.
production.
There's actually a guy in town, he's a former business school student, who's been working on a biomass, biofuel operation here.
Is it Taylor?
Yeah.
Taylor Woods? Yeah, they've made some progress. They got a little mass spec and,
Really early stage trial.
yeah,
going.
yeah,
I
yeah.
think the
And,
biggest problem they're having is to get the impurities out of the gas.
Yeah.
sulfur. And that's one of those technological problems that has to
Right.
happen first
Yeah.
versus the utilization.
Yeah, that's what they're working on, is
Yeah.
trying to refine and make sure the technology's doing what they think it's supposed to do.
Okay, and then here were mine. So we decided we got the flipped classroom, so I had to take my turn as well. And so this is kind of fundamental, maybe more psychological, but how people value their own comfort versus that of others, and it's kind of fundamental. But one of my goals here, I've never written an EPA P3 grant. It's sort of been out there. It's not a lot of money, and so for a lot of times, it's, faculty don't see it as a worthy investment of their time when it comes tenure time. Oh, how much grant money did you bring in? Oh, $15,000 from the EPA. So,
Right.
but that said, we just got a nice
So
$20.
$15,000 for a little startup idea is
Heck, yeah.
a handy bit of cash.
Yeah, and so that's why, I thought if we get it, it'll bring some nice prestige to the university, give the students some good grant writing experience, get their ideas knocked around a couple times, take them. So this isn't something that is critical to me. We've got a nice Department of Labor grant with a big budget that we're mucking around with. I just got a $750,000 NSF grant too that allow us to develop new courses. But I think from first, and this is a student initiated funding mechanism. It's external. We've had some nice QUELF funds available already, so the CLES Revolving Energy Loan Fund, that's internal. But now we can kind of take these ideas that we've already established here and then take them to the bigger world. I too want to delve into the economics of recycling and post-consumer waste manufacturing. We are planning on starting a recycling technologist tier, so we're going to add a recycling technology. We've got about $130,000 to spend on recycling equipment. I want to sit down with Eddie Stan and say, gosh, what if we got an actual grinder and a cleaner and an injection molder? Could we start doing some small-scale injection molding, manufacturing in Missoula? There's already the plastics guys out here, but they're using ultra-high molecular weight, for making, computers and things. But we would just say, gosh, maybe you just want to make a little container or some
Right.
or some kind of pure material. So
Interesting, yeah. I guess there's a sort of continuum there, because at the other end of the spectrum, you've got the upcycle
yep,
guys on
Yeah.
the hip strip. that are
Sure.
Just taking stuff and making like trinkets
Right, so they're using I guess I look at that, they're using the artifacts rather than materials. So you already have some, a material that's in a specific shape, like a bottle cap, like a bicycle tube, and so you're gonna value that as an artifact, something that's already has a recognizable shape, and add some value by turning it into, versus, okay, I'm gonna take the bottle cap, melt it into metal, and then make something, or take the rubber, melt it back down into its simpler polymeric form,
But
so,
maybe there's a combination of those two.
yeah. Yeah,
Recycling the plastic, sort of converting the plastic back into melting it down and using it, and adding these sort of the bubble tops and
right. There's a big things that,
vehicle license plates and things.
Right, yeah.
Make something out of.
yeah. So, yeah, and I think it does take kind of a network approach, some kind of a
Yeah.
distributed.
Yeah.
And then another thing that I want to understand a little bit more is, sorry about that, I was going to turn that off. So policy and predictability versus flukes or contingencies. So we already talked a little bit about the fact that a lot of the markets are regulated, and I think, from a financial standpoint, that's what investors like, right? They're going to put their money in, they know how much they're going to get back, versus just kind of flukes or contingencies, so Enron already came up, there's a book out there called The Big Short, so how much kind of sort of side planning and plotting so in a lot of ways, if the market is, well-established and predictable, it actually allows these sort of, I don't know if you want to call them dishonest, or maybe you want to call them entrepreneurial, disruptive ideas to come in and sort of take advantage of that. Everyone else is in their little cubby hole, pigeonhole doing their thing, and all of a sudden some guy comes along and does it. So, so they're kind of the big pictures. And then some of the technologies that I would really like to explore more, maybe a little of my own, but maybe with this EPA, is taking electromagnetic energy, and so what I mean by that is just sunlight, it's radiation, converting that into thermal energy, so getting something hot, and then that becomes chemical energy. And it could just be, okay, I want to get the sulfur out of something, and so sulfur and oxygen are going to dissociate at some temperature. At some point you get it hot enough, it's going to come apart. So maybe you have your sunlight comes in, you've got your pressure cooker, and rather than, electrolyzing hydrogen and oxygen the way, and maybe there is some kind of catalyst that has to, some other chemistry that has to be in place, but rather than electrolyzing it, your sulfur comes off over here, that has commercial value, your oxygen comes off over here, and that has commercial value as well. So chemical energy basically, taking sunlight, nothing's on fire, sun's not on fire either, it's fusing. So there's no fire. It's kind of this, getting back to this Lovins reinventing fire thing. There's no carbon involved in any of this, and you're adding value by creating pure chemicals just from sunlight is one.
Tie into your post-consumer waste manufacturing.
It could, absolutely, yeah, right. It could. Problem is, you're not going to store energy. This technology would only run when the sun is shining, right? You sort of have this mass that's ready to go, and okay, it's offline because the sun's down, but then it comes back. So the other one, just pure electromagnetic to thermal, and to a large extent, we've already done that. Tim Chester, one of our students, built this really nice solar collector with a little heat exchanger on it for my office. It worked great. It worked so well, it melted itself. He had, so he'd insulated it. So you want this thing to be insulated so you're not just losing air back to the atmosphere. But he used a polystyrene insulation, which has a melting temperature somewhere around 110 Celsius, maybe 220 Fahrenheit. So when his manifold was hitting 240, 250 Fahrenheit, he was melting this plastic. So, yeah, then we're all kind of like, whew, yeah, let's do it. Who broke out the modeling glue? So, and so this isn't really new technology. This would just be more, how do we package it, market it, make it more accessible to the community. And he just built it with some 2x4s, which could be scrap, and aluminum cans, all of which were scrap, so,
Wow.
you know.
Did you have plexiglass plate on
Yep.
it of some kind?
Yeah, he did have the, kind of the corrugated plexiglass on the front.
Which is really interesting, given kind of most people would think, oh, well, I'm gonna get solar power, I've got to buy these
No.
phenomenally expensive solar
Yeah.
panels and put them on my roof.
Right,
I'm
right.
gonna need a $20,000 investment. And
Right.
Whatever, and you're saying you did it with cardboard and.
Right, just probably a couple $100, and it was, and it really was, so a lot of times you'll look on a rooftop,
Yeah.
and, you know, kind of an entry-level system is 2 kilowatts. You know, so you might have 10 200-watt panels, 2 kilowatts, and Tim's system, purely thermal, he had a little over 2 square meters, and it was 2 kilowatts, you know, just
Right.
without, and, you know, the efficiency, we never really got an efficiency measure, but most of that's heat, I don't think a whole lot was
Maybe you
leaving.
could adapt that and even use it to keep their hot tubs warm.
Mm-hmm, yeah, yeah. Supplemental, yeah. Okay, so, and
I was
then,
thinking of making one over the top of a PV cell. Could you do it? Because the photons are going to go through. You don't need the photons in the radiation, you need the heat that carry the photon. Pull the heat out before the photons hit your solar panel, and then your solar panel's cool. All right.
so where's the PV in relation to the solar thermal?
Well, it'd be underneath, so you'd have your solar thermal over the top of your PV, and then there'd be your airspace, and the photon would come all the way through down in, and capture the heat before it went in, so you get photons.
Oh, well, I mean, maybe, I think if you did that, you're gonna reduce the efficiency, well, I mean, I think I still have I have our,
Yeah, it just depends on how much efficiency you would reduce on the photons going in, because that's what you're looking for the electrical conversion. And if you heat up your PV cell too much, then you're losing efficiency anyways.
yeah, let me find that slide, because I kinda wanna get to a graphic. I mean, just hold that thought.
It's already gone, I'm sorry.
Because it's that effect on it's gone.
Oh, shoot, I don't think I stored it. You know what, this is a great opportunity to use my pad, if it actually, if the software loaded, let me see here.
I'm already stuck on Star Trek now.
You're what?
It's a cool idea to capture the heat before or on top of photovoltaic panel, and then the PV still works.
But it's not getting heated up like, it's a novel idea, I mean,
Well,
I'm just wondering how much space you'd need over the top of your PV.
let
You'd
me,
have to have two, basically,
There's gotta be some energy loss that happens when you're.
well, I'll just bring up a photo of the system. Got all our crazy gadgets out there. So, as I know, okay, there's wind turbine, older post. This would have been, I think you're in the photo too, aren't you, Adam? When we installed, well, when we installed the, when we installed the PV on the side of the building.
Oh, the solar thermal?
Yeah, when was that?
I helped Tim build that. That was,
Yeah,
January maybe of 2013.
must have been January 2013. Okay, so this is.
what was that trailer set up for to begin with?
It was, I think it was just a snowmobile trailer. Geez, that thing kind of ended up kind of gross. So maybe, I think that might have been,
In January, maybe you posted the pictures in February.
maybe,
I've seen it, it was up inside your office.
yeah. Well, anyway,
Which isn't there now.
I guess what I'm wondering, if you've got the, and unfortunately, I want my little, let's just throw the sun back in here. Fill that with some yellow. I guess my only concern there, if you've got your solar thermal here, and you've got your PV here, any light coming through that solar thermal, I mean, you kind of want it all to be absorbed by the solar thermal, because it's black. You know, if it's transparent, I'm just,
They just don't go through, I see what you're saying.
the light, I mean, you really want all the light to hit, is all I'm saying on that.
Well, you want the heat to hit the box so it stops everything.
Mm-hmm.
And then you can capture that.
Yeah,
So if I put the transparent bottom on the bottom, you just basically, it'd still throw heat out. It'd still capture some heat.
it just captures some.
But it's still gonna have heat coming out the back.
Yeah, I guess that's my worry, is just like any photon here, you really want them all. I could see well, what we ended up doing though, I don't know if you saw it, we put the solar panel on top of the solar thermal, and the solar panel runs the fan. So you only want to heat, I mean, the only time it's going to work anyway is when the sun is out, and so when the sun strikes the panel, it runs the fan to pump the heat in. So I guess we went with what would this be, a parallel model instead of I think you're talking about a series model. This is more of a parallel.
How about the solar force? Could you take 3 meters of light and condense it down to like a little speck and have a little tiny solar panel instead of a...
Good segue. The raw lemo has been built, but what I'd like to do, similar idea, is go electromagnetic to thermal, and then to electric. So, and this has already been done as well. The Stirling engines that you'll see, but doing something smaller scale. Clay Cooper had an idea, and this is what happens already in a power plant. I mean, but it's not electromagnetic to thermal; it's chemical to thermal. You burn the coal, makes something hot, makes the steam, spins the magnet, and there's your electricity. So I guess what I'd like to do is just take the combustion out of it. Get rid of the carbon on that. Okay, so
It's just sort of.
sure, yeah.
An aside, but at
Yeah.
the weekend I bought, from like Lowe's, the little kind of solar lights for like.
Oh, yeah.
your
Mhm.
Kind of your front yard. and
Yeah,
the driveway.
little battery in there, little PV.
Yeah, and they were like kind of $5 each with kind of plastic tube kind of stick them in, kind of cool. And I'm like, well, I'm sitting here thinking now, well, what if I have a sort of bunch of those that I sit outside during the day, and
Right.
then I get home at night and I just bring a few in. And
Oh, bring 'em in.
Light them up, sort of.
Okay.
I mean, just little bits of light inside.
Yeah,
I
yeah.
don't need kind of full bright light. I
Huh.
just want a little bit of kind of ambient light.
Sure. I like that. Yeah, because you've stored that energy in the battery, and that's typically what they have, so.
Yeah.
That's a good one. All right, that's,
Well, my point was, the big TV screens cost a lot less than making a huge solar panel. So if you could take a 3-meter space of light and condense it down into, 3 inches with the solar panel and condense 3 meters of light down into 3 inches, you would save...
3 square meters?
Yeah, you would save so much on the creation of the PV.
Yeah. Yeah, there are several technologies just like that. There's one, yeah, like this, well, I can show you the one. I like the bring inside PV. Yeah. Yeah, I don't know if you, maybe you didn't, I don't know if you saw it or not, Gary, but during the practicum, here, I'll show you. Jonathan Bowe was all getting crazy with this. So he's got a sphere, and this thing does, and you can barely see it. There's just one little tiny PV on the back end, and it is a solar concentrator. Do exactly what you said to reduce the actual amount of silicon that you have to use.
So what do you do with one of those?
it's a photovoltaic, but rather than having, the giant planar panel right in the back, and like, it's hidden right there. But there's just a little mini
See
photovoltaic.
down there at the bottom?
Yeah,
So it's like.
it's a concentrator.
Can you freeze it on that last one?
And then you just hook that into your
You-
electrical
In your electrical system, exactly. And right now, they're pretty new. I think we looked at the pricing.
149 pounds?
Euros.
That came down significantly. Wow.
We should have bought one of those for the trailer.
We still got $8,000, still time.
How many watts are you
Little,
speaking?
little heavy. Well, it looks like they're trying to show is that this guy could probably power like a notebook, and so 100 watts. Most of these computers are running about 100 watts,
You got your onboard computer system then.
and they're never gonna. Well, these are made for stationary applications because they're very heavy. What you gain in efficiency, you lose in mass.
Mhm.
So,
But I could stick one of those on my roof.
yeah,
For a
exactly.
bunch of them around my.
Yeah. So that's one. Okay, so there are kind of goals. We just added Paul's idea to the bottom, the bring the bring inside
Because
TV.
my house is on the side of a hill, so my driveway's at the top,
Uh-huh.
and so I can't see them from my main living space. But every evening now I go upstairs just to go look at them.
Yeah, yeah.
They're kind of cool. It's like, yeah.
Well, someone else had an idea. It was a bring inside thermal device. So it's something that just a big solar mass that you stick outside during the day, and then you just roll it into your house at night. And it kind of
Just
provides you.
take the glow off it, essentially. That heat.
Yeah.
Yeah.
Similar thing. So, I think maybe what we should do, because there's no way we're going to discuss all 14 of them, maybe we just rank them by the ones that we think are our favorites.
Yeah, maybe get it down to half a dozen and then.
Yeah, I was thinking,
Through the half a dozen.
yeah, even 3 or 4, and then,
Do a more rigorous comparison.
yeah, so what's the best way? Should we each get like three votes, and you're welcome to vote too, Paul, so just keep it different.
Do we want to add
Yeah,
anything
but-
else to the list before we do that?
Well, no, we can add a thing or two.
So, it's
Okay, so the first one was maybe to drive ourselves from Missoula to Detroit for the Shell Eco Marathon, to Washington DC, to claim our prize with no gasoline. So Gary's like, it's already been done, what could you do that's novel or relevant? There's, another one is at least being somehow carbon neutral or carbon negative on the trip. And then Gary's like, well, as soon as you change the tire, you've tapped into some major
Changing the tires, you
carbon
build it,
markets.
and you're gonna have those little nitpickers that say, well, what was your carbon footprint for that tire? Just one tire on it.
Well, sure, it's true, and we can't ignore the last 150 years of history, and, yeah, so,
The interesting idea, which I think that was probably triggered by that sort of careful accounting thing, is
Yeah.
is almost sort of trying to start developing a little sort of like stamp you can put on the side of a kind of product. So people talk about kind of whether their business is what their carbon footprint is,
Okay.
or carbon neutral or whatever. What if you're picking up a can of beans or a bottle of water, and it's like, this is essentially how much sort of energy is being consumed in the production and transportation of this.
Mhm.
Or right alongside with your paper and what we discussed.
which is,
Pick up the curling iron, this is how much.
It's like,
Oh.
I'm not going to buy those Pringles because they
Yeah.
took twice as much energy as the packet of whatever else is next to them. And those sort of things changes
Something
behaviors.
like that in Europe with like electronics.
Could be. Could be, yeah. Though in the same way that people now start to make decisions because of the information around whether it's organic or the calorie information or whatever, it's like, oh, well, maybe I'll make a decision based on how relatively environmentally friendly or unfriendly the production of that product was. It doesn't have to be food. I mean, any consumer good that
Yeah.
you're picking off the shelf.
So I'll add that as like a stamp on product kind of thing. Okay, and the other one, this is pretty relevant, like Hull's Dairy, for example, they're making electricity from cow manure. And their big problem is they've got a lot of hydrogen sulfide. And so, if we came up with some sulfur removal technology. Another one, this might have been mine, I'm not sure, but cellulosic waste to insulation. So people already buy blown-in cellulose. I think a lot of that is already post-consumer waste, but I don't see that happening in Missoula, but it seems like fairly low-hanging fruit. What do? You shred it, make sure it's dry, and sell big bags of cellulose. Another one is polystyrene. So polystyrene is a big issue. No one knows what to do with their little empty takeouts or their meat trays or peanuts, etc. But it's a great insulator, and it's fairly simple chemistry. But taking that, applying a little bit of heat, not the Tim Chester 250 Fahrenheit, but just enough to reform it or reshape it. And then there's another faculty member we have here, Zandy Sievers, who's come up with this very thick 2-foot wall passive house design. So, giving him, cleaning and giving him the raw material to actually make these structures. This is another one, like the non-allied plastics, some like the number 5s that are a little more challenging.
Plastics.
Yeah, so. Another one we thought we'd do, so we've got the wind turbine trailer. I don't know if we'll show it to you here maybe on the next break, but it's right out here in what we call the bullpen. We drove it down to Houston, deployed it there on the Discovery Green, just spent a couple weeks putting PV on it. Gary's team put some compressed air, that's also an energy storage media, but doing a little better education with it. So having the posters, we talked about last time how obtuse my article from 2008 was, like, what the heck's a exajoule? So trying to put some kind of graphic, some layman's education on the trailer that could sort of come along for the ride. And I think it's similar to the stamp on the product, a little bit of information.
Educate people about their choices, they may make smarter ones.
Yeah. Here again, it's thermal to electric for transportation. That's kind of a tough one. Whose was electricity demand reduction? Was that?
Very big, I know.
Okay.
I was just trying to think of other kind of sub-ideas underneath that, kind of like kilowatt meters,
Demand
Okay.
reduction, like, I think that goes with his first one, the consumers, what are they willing to give up for other people?
Mm-hmm.
What do they value their energy at,
Mm-hmm.
Because I'm sure that somebody in America is going to value getting up in the morning and walking over and turning on the light as opposed to somebody in Ghana that doesn't have that luxury.
Mm.
Right? They're saying, well, I don't value that because that's not an option for me.
Mm-hmm.
There's a couple of sort of different
Yeah.
models around that. One is the kind of the Tom Shoes type model.
Who's it?
Tom Shoes. So Tom Shoes is this business that's grown up where you buy a pair of shoes and they basically give a pair of shoes to someone.
Oh, yeah, okay.
And then what I was going to say. Will come back to me.
I saw the Tom Shoes work. There was a guy came through town, had a little portable solar oven.
Uh-huh.
And, they're kind of like, high-end materials, a lot of reflective materials, almost like a vacuum tube.
Yeah.
And so it was very expensive. You're like, gosh, do I really want a $50 hot dog for lunch? But what he did was something similar, I think, where if you bought one of his, you're sort of buying it for double the price. And I mean,
Yes.
it's already so high anyway.
Yeah.
You sell it to someone who can afford
Tom
it.
Shoes is super expensive.
Okay.
Because obviously the quality of shoes that perhaps you can give to someone in the third world doesn't need to be fantastic. This needs to be functional and
Yeah.
kind of durable.
Yeah.
So that doesn't need to cost a huge amount of money. And now there are other people coming up with essentially taking that one-for-one model in different areas. So actually the team that came second in Startup Weekend here is a startup business called Temp Out, and they're taking that same philosophy to feminine hygiene products.
Was it called Tamp?
Out.
Oh, Tamp Out?
So the
Like
idea
that?
is that women would subscribe to tampons, and the ones they'll Temp Out would then
Donate?
provide feminine hygiene products for people and women in the third world.
I see,
Because
okay.
women, a lot of them don't have access to them, so it means that a few days a month they can't go to school or they can't go to work.
Okay,
Vulture feathers.
what is it?
Vulture feathers.
Oh, I don't know.
I was watching a documentary film last night, where women in South America use the inside down of the vulture feathers.
But it's another sort of interesting, that demand reduction thing. I think it's, when I was making earlier about sort of how do you engage and motivate people to
Yeah.
change their behaviors in some way.
Yeah,
I
yeah.
still want an electric snowcat.
You can-
I think electric snowcats and electric motorcycles would be like neat, like if you could make a really high-powered electric engine, kind of get it lightweight, put it on one of the, like one of the little, bikes for pleasure rides,
Right.
dirt bikes and stuff.
Mhm.
You could get one that you could do that with, because nobody rides that thing 24/7. They're so, I mean, even
But I
the best
presume
riders.
they'd be much less noisy as well.
Yeah, well,
There's
some
lots of
people
noise
like the noise.
pollution.
There's electric Harleys out there that people are bad because they don't make enough noise. But I'm thinking, most people can't ride those things for more than 2-3 hours, more than 7 hours. What can you get for battery life on one of those, and how can you extend that battery life? And I was thinking a snowcat would be neat, because I think it's a novel idea. I've never seen an electric snowcat, I've never really heard of an electric snowcat. Plus, you don't need roads for snowcats. You don't usually make like a big track or a trail, because what you go through in the snow, it just melts. The problem is it's weight.
I'll get you in touch. There's a gal in Jackson Hole who kind of heads the electric vehicle push in the Pacific Northwest. Another one we talked about, landfill free for the campus. That's, I don't know, that seems probably a little ambitious for this. It's sort of, maybe the next step from one of these waste reductions or waste repurpose thing we talked about. Then we talked about seasonal thermal storage. So if and again, this has already been done. You've just got a giant tank of water underground that all summer you're pumping heat into it, and then you draw from that during the winter, and then you'll have either a separate tank or maybe the same tank, it's depending on the strategy, that you're freezing all winter, and then you're pulling cool from it in the summer. We also talked about supplementing the heat just from compost, just from the gas, just from the metabolism coming from composting, and or just solar or burning the biogas. Different ways to make that heat.
That's gonna have to be in tandem with three if you're gonna burn it. And if any sort of burning, so you're gonna have to get sulfur.
Yep.
involved.
Yeah, so a lot of these are related. And then next one, some way to push towards this carbon neutrality. I don't think our EPA grant is going to achieve that, but some measurable way to move toward that goal. And here's Paul's bring the PV inside, and then maybe we could incorporate one of the, and I'd never heard it called that, but 1-for-1 model. Is that kind of a standard? Okay.
Black pair of shoes.
Yeah. Yeah. So.
You get a tax write-off for that too, wouldn't you?
Possibly, yeah.
You're gonna have to get a tax write-off for that. I mean, you're donating a product, it's not like you're donating your services.
So I thought let's just look at the EPA criteria one more time, and then we can vote on what our top 3 or 4 are, and then maybe we just spend the last hour deciding. And then we,
I can maybe throw out a few just sort of macro criteria that you might want to use.
oh, sure,
Both in terms of sort of evaluating the list, and then we might sort of drill down.
okay.
And these are kind of statements you can take and agree with or disagree disagree with.
Yeah.
But things that might be interesting to think about is what's the really sort of the market potential and kind of impact of any of these ideas.
Okay.
So some of these things clearly could have sort of global applicability. You've got the technology or the product or business model that can be applied in multiple locations,
Mhm.
as opposed to if you do a landfill-free U Montana campus. I mean, sure, in concept that can be done lots of other places, but you're really focusing on an impact here. So when you choose these, what's your ambition?
Yeah.
Your desire to kind of have an impact?
Mm-hmm, mm-hmm, mm-hmm.
Second would be, what's the power of the story? Because when we deal with sort of entrepreneurs, and we actually did a kind of session last week, so I don't know if Jeremy saw it. So Jeremy's a guy who lives in town, but he's a Paramount Pictures executive.
Oh, really? Okay.
So he's a marketing exec, so his job is actually making the trailers for movies.
Oh.
So he's like,
Oh, nice.
How do we pitch? He both sees how movies get pitched to potential movie studios, but also how do they do a trailer for a movie that makes, when you're sitting in a movie waiting for your movie coming out, like, oh, I want to go see that movie.
Absolutely, yeah.
So he talked about kind of the power of the story and how you kind of pitch things. So partly for the EPA, but also in terms of actually having impact with this, the ability to create a compelling story around it, and engage people like, oh, that's really cool what you're doing with that, as opposed to, you know, it sort of sounds kind of geeky.
Right. Yeah, okay.
So, and then I think
Good, that's good.
almost just the ability to really build a sort of business model around it.
Yeah.
So there are sometimes some of these things that sort of they're kind of a little kind of project initiative-ish, and you're sort of, it's cool that they did it, but you're not quite sure what you do with it now that they've done it.
Right.
So which of these has real potential to actually, could you create a business model that means you could scale it up and sell it and deliver it?
Yeah.
That's what I was kind of thinking, macro statement would be entrepreneurial versus technological. Basically, do we have to develop the technology, or do we have to market it? To find a different way to market it, because, you know, it's already developed, and you find a new way to market it. Who ain't gonna get the market? You're saving a lot of money in your development costs, so it's kind of a capital and a return statement.
I like that.
Yeah.
I'm gonna, maybe I'll do this during the break, but I guess what I'll do is, are those the three then?
Those are the ones that occur to me.
Okay.
off the top of my head.
Those look great. I mean, that's good. That's stuff that you don't learn in engineering school. What I thought we'd do,
Because I don't have a technology background, but I spend lots of time working in high tech, and particularly in the telecom industry, you get lots of sort of software and communications engineers saying, hey, it's really cool, we've done this, this, and this. And I'm like, yeah, but what does the consumer want now? And how much would they pay to have that capability?
So, I thought we would do, let's just do this.
Or maybe I'll add one more, and again, you can sort of, you don't have to take these as absolute things, you can sort of discount them.